Good morning, grade 10. This is Mrs. Pascale. Today's lesson is chapter 10, section 10.3, radical expressions. The objective of this section is to reduce radical expressions. We will start by correcting the homework. Number 1, the expression 1 radical 5 plus 6 radical 5 gives 7 radical 5. The expression 12 radical 5 minus 3 radical 5 gives 9 radical 5. Number 3, 4 radical 2 minus 7 radical 2 gives minus 3 radical 2. And number 4, we have radical 63 minus 2 radical 7. So we don't have identical radicals. We need to try to reduce the writing of 63 into product of prime factors. So it's radical 3 squared times 7 minus 2 radical 7. Reducing the first radical, it gives 3 radical 7 minus 2 radical 7. Finally, the answer is 1 radical 7. In number 5, we have 5 radical 5 plus 3 radical 125 minus 7 radical 50. The expression contains different radicals, so we need to try to reduce each reducible radical. Radical 125 can be written in the form of radical 5 squared times 5. Radical of 50 can be written in the form of 5 squared times 2. So the expression will be in the form 5 radical 5 plus 3 radical 5 squared times 5 minus 7 radical 5 squared times 2. Reducing a radical of 5 squared, we get 5 radical 5 plus 15 radical 5 minus 35 radical 2. Adding the identical radicals, we get 20 radical 5 minus 35 radical 2. And this is the final answer since we don't have identical radicals. In number 6, radical 2 into radical 5 minus radical 6. First, we need to distribute the multiplication. So it gives radical 10 minus radical 12. Radical 10 cannot be reduced since it's the product of two prime numbers, 2 times 5. Radical 12 can be reduced into radical 2 squared times 3, so we get radical 10 minus radical 2 squared times 3. The final reduced form is radical 10 minus 2 radical 3. Again, this is the final answer since we don't have identical radicals to be reduced. In number 7, radical 15 into radical 5 minus 3 radical 3. Distributing radical 15, we get radical 75 minus 3 radical 45. Radical 75 is radical 5 squared times 3 and radical 45 is radical 3 squared times 5. So reducing this expression, we get 5 radical 3 minus 9 radical 5, and this is the final answer. To continue where we stopped in the previous video, we were discussing multiplication over radicals. Today we will see multiplication depending on remarkable identities. And number 1, radical 2 plus 1 to the power of 2. It's like the rule, a plus b square, so it needs to be distribute or expanded in the form a square plus 2ab plus b square. So it gives radical 2 square plus 2 radical 2 plus 1 square. And after applying the rule, we can reduce the answer. It gives 3 plus 2 radical 2. Another example on the same rule, 2 radical 3 plus radical 5 all squared. It gives 2 radical 3 to the power of 2 plus 2 multiplied by the first term, 2 radical 3, then by the second term, radical 5, Then added to radical 5 square as a square plus 2ab plus b square. Reducing this expression, we get 12 plus 4 radical 15 plus 5, and finally 17 plus 4 radical 5. And number 3, if we have radical 2 minus 1 squared, it's like the remarkable identity rule a minus b squared. It should be expanded in the form a squared minus 2ab plus b squared. So it gives radical 2 squared minus 2 radical 2 plus 1 squared. Reducing this expression, we get 3 minus 2 radical 2. Number 4, 2 radical 3 minus radical 5 squared. It gives 2 radical 3 squared as the first term minus 2 multiplied by the first term, 2 radical 3, then by the second term, radical 5, added to the square of the second term, so it's radical 5 squared. Reducing this expression, we get 12 minus 4 radical 15 plus 5, so it's 17 minus 4 radical 5. Now, if we have product of two factors in the form of a minus b into a plus b, it gives a squared minus b squared directly. So radical 2 minus 1 into radical 2 plus 1, we can directly write the square of the first term minus the square of the second term, and it gives 2 minus 1, so it gives 1. Radical 5 minus 3 radical 2 into radical 5 plus 3 radical 2. Taking the square of the first term, it gives radical 5 square subtracted from the square of the second term. We get 3 radical 2 squared, so it gives the final answer as negative 13. Rationalizing a denominator when the denominator is in the form of sum of two terms or difference of two terms, like number 1, 10 over radical 7 minus radical 2. To remove the radical from the denominator, we need to get a difference of two squares. That's why whenever we have difference, we need to multiply the denominator and the numerator by the conjugate of the denominator, which is radical 7 plus radical 2. By multiplying the fraction by radical 7 plus radical 2 in the numerator and in the denominator, we get 10 into radical 7 plus radical 2 over the difference of the two squares, radical 7 square minus radical 2 square. Reducing this fraction, we get 10 into radical 7 plus radical 2 over 5, which gives finally 2 into radical 7 plus radical 2. Taking another example, 7 over 3 plus radical 2. Since we have 3 plus radical 2, we need to multiply the numerator and the denominator by the conjugate of this factor, which is 3 minus radical 2. And we get 7 into 3 minus radical 2 over 3 square minus radical square. So we get the reduced fraction 7 into 3 minus radical 2 over 7, and as final answer 3 minus radical 2.